this. Short after the First World War, thank you. Um, Short after the First World War, the International Astronomical Union was founded because astronomers all over the world wanted to um, continue the work without the affection of global political struggles like a world war, because the world war affected the interaction, the communication of astronomers, their collaborations, and so on. And then after the war, they wanted to have a body, a scientific body that sets global international standards, because there are billions of people on Earth, but only roughly 10,000 astronomers, and these few scholars wanted to communicate. They defined the modern constellations as a sort of communication standard to tell everybody this and that star is at this and that place in the sky. So they needed to agree upon a system, and these dark red lines that you can see here are the borders of these constellations. So this is the result that they defined in, say, 1930, and they started have to name these um, areas in the sky with names in Latin and a system of 3 letters for abbreviating these Latin terms. Like Ursa Major was now or is now abbreviated with the 3 letters UMA, or Camelopardalis, a very long Latin, originally Greek term, is now abbreviated CAM. And that's it. And that's much easier for the written communication. In 1922, they agreed upon this system of 3-letter abbreviations for all the Latin terms, and there are 89 of these abbreviations. And only 3 years later, they agreed upon the borders of the constellation, and then one of these 3-letter abbreviations, which is the abbreviation of the constellation Argo, was obsolete, because the huge constellation of the ship named Argo was then subdivided into constellations, and now only the 3 divisions are used, and not anymore the umbrella term that summarizes all 3 names. So now, since 1928, we have 88 official constellations defined by their borders as displayed here and named with the 3-letter abbreviation system. In 1930, the man who developed all this, who was given the task by the IAU to develop the system, the borders of the constellation areas, a Belgian scholar called Eugène Delporte, and he published his atlas with this new standard in 1930. Okay, so what sources did he use? How did he make these constellations? He basically used the constellations of Greco-Roman antiquity, because what has been written down in 130 CE in the Roman Empire was used as a compilation, as a new standard sort of school book for academic astronomy in at least 3 religious context: in the Christian, in the Islamic, and in the Jewish context. And all 3 religions in their religious astronomies have used this standard, used and developed this standard that had been written down in 137 CE. The Almagest is already a compilation. It's based upon earlier, and in the 2nd century CE, just sat down, maybe not only one scholar, maybe a group of scholars sit down and summarized and sort of standardized what had been written before in the previous century. This is already a fusion and a next step of evolution of the Greco-Roman constellations and knowledge. Oh no, sorry, I'm going back. Not my own laptop computer, sorry. Um, so you can easily check in the Wikipedia that in this book there is a lot of information of different types. There's information about the motion of the moon, about the motion of the stars, about the motion of the planets, sort of computational models and algorithms, how to their future positions and their past positions. And this is written in the Wikipedia. This is a copy of a screenshot of the Wikipedia. So you can easily check just in the English Wikipedia, and then you will get this. And here, for today, we can, of course, not go through all these topics. I'm just focusing on the stars. And what is interesting here that the underlying model for all this is that Ptolemy had imagined the stars as a sphere surrounding the Earth, and the Earth for him is a sphere. So we have a spherical Earth in a spherical sky. So the tiny Earth in the big sphere of the stars. And the stars are described in books 7 and 8 of the Almagest. This is highlighted here now in pink. And I will get back to that topic immediately and in more detail. But before that, I want to tell you some overview things, which is I mentioned that in the 2nd century, when Ptolemy wrote his book, or the school of Ptolemy wrote their book, this was in the Roman Empire. So the language that was spoken in, say, the administration was, of course, Latin. But the lingua franca, the sort of language that now is English, that was used by the academic people, was still ancient Greek. So the book is not written in Latin, although it was the Roman Empire. The book is written in Greek. And this is interesting because it already shows a mixture. And then if you get to the any dates, because for instance he cites some observations, historical observations of the stars, of solar eclipses, of lunar eclipses, and these observations throughout the previous centuries are all dated in the same or transformed in the same calendar system. And Ptolemy was based in Alexandria. Alexandria is a city in northern Egypt, in the Nile Delta, close to the Egyptian coast, and that is why he uses Egyptian month names. Not the Roman ones, not the Greek month names, the Egyptian month names. And to increase confusion, he counts the years, not in the Egyptian way, not in the Latin way, ab urbe conditio, up the foundation of the city of Rome, and not at the Greek way, but the Babylonian way of counting years after the Babylonian king Nabonassar. So this is a huge cultural mixture that is made or artificially made in this book, and shows that he really wants to unify many traditions from many, say, sections, areas of the huge Roman Empire. He wanted to unify many traditions in his world, which was the Roman Empire. Of course, he didn't know Indonesia. Also, he made another book, which is the book of geography, which is not included in the Almagest. And in his book of geography, he tells how to project the map of the world, of his known part of the world, on a plane, because he knew the Earth is spherical, is not flat, is curved, and how to project a curved surface onto a plane. This projection actually came upwards. It's preserved only from a few centuries later, from the time. Not really Ptolemy's time, but a few centuries later, but which is not our modern projection style. So he also invented the mathematics. Had the mathematics to project the sphere
This is just to tell you that he did those kinds of problems. Going back to the stars, which I will today, I'm going to show you star patterns. By the way, the lecture is also recorded. You can watch it later. The star pattern this is a big reserved from 12,000 years ago, not 2,000 years ago, but a Greek manuscript really everything very good. But you can clearly see that this has a tabular, it's a tabular shaped with a catalog. It's not plain text. And the red headlines are the names of the constellations in red. But here it's written also in blue. And then descriptions of the stars, like the star on the tip of the tail of the she-bear. The star next to the tip of the tail of the she-bear. The star next to it. The star with the tail of the she-bear joins the whole body of the bear. And these descriptions have later been translated into Arabic and then have been abbreviated and misunderstood and so on. And our modern star. Also, then he gives per description, per name, per star name, he gives one ecliptic longitude, one ecliptic latitude in an orthogonal coordinate system as we use or could use it today. And then he gives a magnitude. Magnitude, of course, is an equivalent to the brightness, but he had no means to measure the brightness. He did not have any means for photometry. These magnitudes are mere estimates, and they have been not always they have been accurate estimates or measurements of the brightness, but sometimes they are a little bit changed because these magnitudes or the whole star catalog was written down as a tool for making globes. And if you want to make a globe, then you need a sphere, a ball, and then you need for engraving or painting this at the correct position. You need the position of the star, of course, and then you need a template, a little template, either this size or a little bit smaller or a little bit bigger to indicate the star at its specific position. These magnitudes are the sizes of the templates. And that is why they are sometimes for more important stars, they are a little bit increased, and less important stars, they are a little bit tinier than in the sky, possibly. Not all of them, but there's a huge error bar. Okay, but we can, of course, use these this information, these latitudes and these magnitudes, to map Ptolemy's star catalog to our modern star chart. And this is what I've done here. In blue are all the stars that are in his star catalog. In white, the white dots are the stars that that we have in our modern star catalog that we know today, but that have not been in his star catalog. And you see that his star catalog is almost complete, at least until 4.2 magnitudes. And then I summarized the constellation areas that he displayed with a mathematical procedure, which is called convex hull, which gives us these polygons. A convex hull, you can look that up in any mathematical book, is the smallest polygon that summarizes all points in an area. So if you have a distribution of points randomly distributed, and then you want to find the smallest area that summarizes all of these points, this is a convex hull. So I used this procedure here. And then, of course, we can use these constellation areas and
reconstruct how Ptolemy imagined the constellations, the images, because we know what star is in the right shoulder, and in the left shoulder of the hero, and what star are in the head, stars are in the head of the hero, what stars are in his hands or legs or feet, or in his club or sword that he is swinging, and so on. So we can reconstruct these constellations because of the star catalog. So I already gave you the impression that we wanted to join many cultural traditions. And what he did was reading books been written by that have been collected in the Library of Alexandria. And then he sort of made one unified new version of it. And this has been done before Ptolemy already. So the Greek tradition already provided this information because of the campaign of Alexander the Great, who originated from Macedonia, which is north of modern Greece. And then he went through modern Turkey and then went to Egypt, where he became sort of king, sort of pharaoh of Egypt. And the Egyptians invited him and really greeted him and welcomed him as their new sort of pharaoh, king, new ruler. And he acknowledged their welcoming by using their oracle. So he went to a specific Egyptian temple, went to the oracle, and let the oracle, the Egyptian sort of tradition, tell him his fate. And this was considered as an acknowledgement of their culture by the Egyptians. So the Egyptians then thought, well, this new ruler who came here and he sort of adapts some things of our tradition. And that is why we are fine with that he is now the new ruler. So Alexander, adapted some of the habits of Egypt. And then after a while, he went on to Babylon, conquered Babylon, and did the same. And in Babylon, it was particularly interesting for him and his scholars who went with him on the campaign to have the Babylonian astronomy, because the Babylonians were considered the most important, the best astronomers all over the known world. So the scholars, like Aristotle, was a contemporary, the teacher actually of Alexander the Great. And Aristotle called his nephew, who joined the campaign of Alexander, if you come to Babylon, then please, please, please bring me some astronomy from there, because they are so great in doing astronomy. So Alexander adapted the Babylonian astronomy and culture of science, so to speak, to make better predictions. And then he went on for political reasons. He went on to Persia, conquered Persia, and also there he adapted some of the habits of the Persian court. And then the Persians also welcomed them as their new king, and so on. So the same happened as before in Egypt. But of course, he then had to chase the Persian king because he was not very, very good with the new emperor, and went away and fled to somewhere in the east. And then Alexander was chasing him to several places, and finally went back to Babylon, where Alexander, finally died. But then the Babylonian and Egyptian and Persian cultural traditions have went into the new tradition of the new empire, the habits, the culture, and everything. And they really invented something new. And this new culture that they newly defined, newly invented, they then called Greek. Remember, Alexander was not Greek, he was Macedonian, and they invented something new because then they had a sort of they thought, world empire. So the whole world, as they knew them, was joined into one empire. And this new empire then was called Hellenistic or Greek. So this defined new standards. And in this empire, of course, there had been a Greek tradition before, like Hesiod and Homer and Aristotle, the teacher of Alexander. But then they defined a new Greek tradition, namely by the poet Aratus, by the librarian Eratosthenes, librarian of Alexandria, the city that Alexander founded in ancient Egypt. And then later, great scholars evolved during the course of the time of history, which was, first of all, Hipparchus, who was as famous as Einstein is today. So in antiquity, he was considered the Einstein. And his work was then reorganized, improved, say 260 years later by Ptolemy of Alexandria. Throughout all these Greek authors, parallelly and also parallelly, the Babylonian tradition was continued. The Babylonian tradition is much older than the Greek tradition, as I said. Babylonian tradition, but the Babylonian tradition was also developed over the course of the centuries of the Greek flourishing tradition. And even before the campaign of Alexander and Alexander the Great conquering the world, his known world, the zodiac was invented by Babylonian scholars. This happened roughly 400 BCE, 400 plus minus 10 years. And this is actually the zodiac as we know it today is actually a new frame of reference, like a coordinate system. They had in Greek and also Babylonian tradition after 400 BCE, they used two systems. One as a frame of reference. One is the historical tradition of constellations, and the constellations are deeply rooted in cultures. So each and every people, each and every local tradition, like the people in Athens, like the people in Egypt, the people in Mesopotamia, they all had their own constellations. So the constellations are deeply rooted in local religions, in local um, natural environmental constraints. And the coordinate systems and the zodiac are a sort of schema, a mathematical frame of reference. And here you see the depiction of the frame of reference in the Almagest, like Ptolemy defined it. I already explained how I reconstructed these polygons of the constellations. I just blended out the stars here. So the polygons indicate the frame of reference defined by the visual dots of light in the sky, the stars. And the orange schema below the blue polygons are the signs, the zodiac signs. This is a division of the path of the moon of the ecliptic in 12 equal sections. And you see they may have the same names as the ancient constellations, like Taurus, Aries, Gemini, Cancer, and so on. The same names, but they are different. The positions are different in the sky. And this already caused some issues, not really big problems because everybody knows about that, but some issues in antiquity. Now I want to briefly explain how I reconstructed the other constellations of other traditions than the Almagest. From Hipparchus, we know that he made a star catalog, but the star catalog of Hipparchus is not preserved. Pliny, the elder, just tells us Hipparchus made a star catalog, but we don't have any any historical source preserved. We know that he made a globe, but of course, the globe is not preserved. We know that he invented a new method to make globes, because this is preserved in the Almagest. And we know that he wrote a commentary on the poet of the earlier um, poet Aratus. And this commentary is the only work that is preserved by his own hand, by Hipparchus's own hand. Commentary looks like this. You cannot, sorry for the brightness. This is a piece of the commentary as documented in like 1,000 years ago, handwritten ancient Greek, copy of a copy of a copy, of course. But from this, we can extract the data. I wrote the English translation above. What he writes here is a list of, this constellation rises and simultaneously some other stars rise and so on. And this gives us a huge set of data. Here displayed in an Excel spreadsheet. You, of course, don't have to read that. This is just to display. It's a huge set of data. And this data we can now evaluate, we can now process with a modern computer. And this is a diagram from a dissertation. That is why it's labeled in German. Hipparchus gives us 505 designations, 365, 320 identified stars. So star names like designations like the one in the shoulder of somebody or something like that. But not all of them. Sometimes he labels or he designates the same star with two different names. For instance, there is the star that is in the mouth of the southern fish, which is simultaneously the southernmost star in the outlet of Aquarius. So two names for the same thing. And that is why we do not have 320, not 300, sorry, we have only 320 identified stars, but 505 designators. And the rest of this list is not important here because I don't want to go into these details, but I want to tell you that he gives not only the list, the culminating stars and so on that I'm just displaying, but also in another part he gives stars that can be used to determine the hours. So you can divide the sphere in 24, the celestial sphere in 24 hours of the day, and each hour line can be defined by some stars, and this is what he also gives in another part of his commentary. So So with that, we can reconstruct the right ascensions and declinations of, say, roughly 320, maybe a little bit more stars. With exact computations, we can reconstruct 8% of his star catalog, because we know his star catalog had um, roughly 800 entries. And with some additional assumptions and some estimates, we can reconstruct roughly 40% of the star catalog, roughly 320 stars with coordinates. And then we can use these stars and draw the polygons as we did for the Almagest. And now we have the blue polygons by Ptolemy and the green ones by Hipparchus. And now you see why I was blending you with the green colors and blue colors before, because I use one color per author. So blue for me is always Ptolemy, green is always Hipparchus, red will be Eratosthenes, and yellow will be Aratus, and brown will be Clay Tablet, the Babylonian works. So you can see the polygons by Hipparchus differ from those of Ptolemy. And then we can reconstruct, of course, also the constellations, how Hipparchus imagined the figure, what images did he have in the sky. And for the small constellation of Crater, a crater is a vessel, a sort of bowl or cup. Um, and there have been many different sorts of craters in antiquity. The Greek word crater is just something with a wide open mouth. You also can have an amphora, which is a narrow mouth, and a crater has a wide mouth. So imagine the crater in the sky has been imagined differently by Hipparchus and Ptolemy, and we can make stick figures of these different imaginations. So Hipparchus had something like this in mind: a crater basic, basically originating from roughly 730, of course, BCE. Um, and Ptolemy had something like that in mind, which was the later form of the crater. So we can really sort of reconstruct what they thought when they wrote their lists. And then what can we do with Eratosthenes? Another color, another author. Eratosthenes was a man from modern Libya, from a province which is called Cyrene, the neighboring country of ancient Egypt. And like later, sometimes a princess from Cyrene was married to a prince of Egypt in order to make politics, in order to make peace between the two countries. And Eratosthenes, the scholar, came with this princess who married the prince of Egypt in order to teach their future children. And Eratosthenes was already a known, well educated scholar at that time and became not the court astronomer, but the librarian who was in charge to maintain and to add to the famous Library of Alexandria. This is a photograph of the library, of a part of the library, which is still preserved today. I took this photograph in Egypt, in modern Egypt, Alexandria. But the main part of the library, of course, was burned in antiquity and is not preserved. But this is an underground part, which you can visit today if you go to Egypt. And you can see these niches in the ground, and there they stored their scrolls, their pergaments, their books, so to speak. And this is a translation of what we can reconstruct of Eratosthenes' book of astronomy, which is definitely not all of the book. And here you have um, a reconstruction of the book, of the Greek version on the left-hand side, and a German translation of the right-hand side. There's also a French translation, but the German book is visually more telling. That is why I'm using that now, and I will give you the English translation in a few seconds. So don't be scared. Um, so this is the reconstruction. I just want to use to show you the layout. Here is the Greek version, one version of the Greek part of Eratosthenes, and this is the second version of the Greek part. So they can reconstruct, they draw, they use some books, say from Byzantine time, half a millennium after Eratosthenes. There are some commentaries to commentaries preserved from which modern philologists can guess what Eratosthenes had written. But in some cases, there are two versions because the reconstruction is not accurate. So this is the second version of the reconstruction of the Greek part. And if they have the Greek part, then they can translate it to modern languages like German, or this part translated to English. The first part I don't translate because it's only because it's mythology. The second part is the astronomy, and for this I give you the translation here, and you can read the English translation, which says something like, in this case, the Scorpion or any other constellation has two stars in the claws, and then on the front there are, like in the forehead or in the eyes, there is a star or two stars, and three stars are three stars in the forehead. In the middle, there is a bright one. In the middle of the whole body of the scorpion, there is a bright one. And there are actually three stars because next to the bright one, there are two fainter ones. And then there are two stars on the abdominals and five on the tail and two in the stinger and so on. And then there is a strange passage which only exists in one of the two Greek versions. This is why I put it in parentheses here. And this strange part says, among all these stars in the constellation of the Scorpion, there is one bright which is the brightest one of all and is at the northern claw. And everybody who has seen the scorpion in the sky knows that the brightest star in the constellation is, of course, in the heart of the animal and not at the northern claw. You can go out at night in the evening in this season and watch the scorpion. And if you don't believe me, you can check yourself. There is no bright star in the claw of the scorpions. So what's going on here? That's strange. Eratosthenes was a very clever man, so he probably did not make this mistake. He knew what stars are at what place. So what we have here is, well, some people, some astrophysicists or Chinese people may think that there's a guest star, a nova, a supernova, something's flaring up there. But this is actually not the case because the Greeks didn't have this concept. So here, they probably either Eratosthenes himself or probably more likely one of his sources have mistaken a planet that was drawn at this position for a star. Because in antiquity, in particular in Babylonian sources, and also in the contemporary Egyptian sources, due to the Babylonian tradition, which has been taken over, they drew the planets among the constellations. And of course, planets move. So, in order to not cause confusion with the stars that do not move, they have painted or engraved the stars, or the planets, always at the same specific position. So, everybody knows, every astronomer knows, there's no bright star at the claw of the scorpion. So if there is a bright object drawn, this must be a planet. So probably, so most astronomers knew, and probably also Eratosthenes knew, but his later copyists or his earlier sources maybe did not know and mistakenly wrote that there's a bright star at the claw of the scorpion. Simultaneously, there are some actually very interesting things in Eratosthenes' work, because for whatever reason, Ptolemy and Hipparchus, the later authors in Greek, they completely ignored Eratosthenes' work, which is a pity for them, because then they missed some information. As you can see here, the red polygons roughly indicate my reconstruction of Eratosthenes' constellations. And in particular, in the south, there are areas in Eratosthenes mentioned that have not been taken over into Hipparchus's and Ptolemy's blue polygons. The red polygons in the south are bigger. Here, for instance, here is is the arrows displayed? Here's a region where Ptolemy, where Eratosthenes mentions a star cluster below the keel, the southern part of the ship of Argo, which has not been mentioned. There's no star cluster in the Almagest star catalog mentioned south of the keel of the Argo ship. And this star cluster can be identified with the star cluster that is now in our modern star catalogs designated IC 2601, or the Southern Pleiades. It had no name in antiquity because it's not displayed, not mentioned in Ptolemy's star catalog. But Eratosthenes mentions it. So Eratosthenes, the clever librarian, probably had sources from further south in Egypt or in modern Sudan. And also, there is a constellation newly invented by Eratosthenes, which is now called the Hare of Berenice. Berenice was the princess who from Libya who was married to the Egyptian king, so the princess with whom Eratosthenes himself came to Egypt. So he sort of projected her famous hair, the hair of his queen, into the stars. Um, there is some political reason. There's also a famous fairy tale, but I don't have to take the time now to tell the story. It doesn't matter, but the important information is that he changed the definition of the constellations. Um, Before him, Aratus did not have this constellation and did not have some other features of later ancient Greek constellations. He did um, make a poem, a didactic poem that has been learned by all school children in antiquity, because it was a poem. They could easily recite it like you recite the Quran. And by reciting and then memorizing this poem, they could learn the astronomy. And that is why it was not only taught in ancient schools, in primary schools, elementary schools, it was also sort of displayed as a theater play in ancient theaters occasionally. So everybody, really literally everybody knew this poem. This was basic education. And the purpose why he did that is unknown. We do not know if somebody gave him the task to do that, but we know that later, after he did it, it became really popular. So this poem is something like an ancient planetarium show. Everybody knew it, everybody used it, and everybody was grateful, thankful to have it. And this poem was not only used by many ordinary people in antiquity to determine the calendar, but by sailors, by farmers, and also by globe makers before Hipparchus invented a new method to make a scientific globe. So much simpler globes used by ordinary people were made with this method by using Aratus constellations. This is a poem just to give you a glance how it looks like. You can buy books with modern translations, also, of course, in modern English, probably also modern Arabic. And the idea is to make a globe by having a sphere, then engraving the most important lines, which is the celestial equator, the ecliptic, the tropical circles, and if you want, also the circumpolar circle. And then, of course, some meridians, like the one that goes through the four ones that go through all the four main cardinal points of the year, the solstices and the equinoxes, which are called color circles. And these meridians and these few lines give you a very rough grid. It's not as accurate as coordinates, but it's a rough grid. And this grid can be used to attach the figures, like the hand of somebody lays at the tropical circle, and the other hand of the same person lays at the equator, and the head of this person lays at the color of I don't know what. And this has been done with the figures, like you can see here. I painted just one piece of one of the ancient globes, and you can see Hydra, the water snake, with the raven and the crater. And the snake is really a snaky, curly line, sort of surrounding the celestial equator on this globe. So the Hydra constellation is attached, is drawn as a snake like this, and then attached to the equator. And this is also done with more complicated figures. And this gives you the whole, or gave them the whole ancient globe in a very rough way. So the constellations have been used to give a rough orientation without any coordinates, just with the lines. And there are also some ancient Babylonian reminiscences in Aratus. So you can clearly see that Aratus, did not only have older Greek sources, but also older Babylonian sources. Like, for instance, he says there are the constellations of the bears, the she bears, two female bears in the sky. The bears are the Greek one. And then he says these bears are also called wagons, the wagons or chariots. And this is the same name for the Babylonian constellation, the Babylonian name of the same constellation in the sky. So he also joins several traditions from different cultures. And the Draco snake, the snake that we now call Draco the dragon, indicates the pole of the sky for the ancients. That is why it's important for him. I don't want to go into this detail, but this is a Delphi tradition that he uses for indicating the celestial North Pole, like the navel of the sky. Okay, let's go to the Babylonian constellations. From Babylon, much older, we have an earlier compendium, and this compendium is called Mulapin. Mulapin is a Babylonian term that literally translates the Plough constellation, but it's the name of this work because it's the first name of the ancient text. And if it was copied throughout a millennium, if other sources referred to it, other Babylonian scholars wanted to make the reference to this well-known compendium, then they called it by its title Mulapin. And it is written typically in two parts, which are in most cases written on two clay tablets, but it can also be written on three tablets or only one or four, doesn't matter. It always has two sort of units of content. And these units are first the description of the static sky, and second, the description and definition of all changes, like the changes of the shadow of the gnomon throughout the year, the changes of how long a night lasts, one night divides into 3 watches, a daylight time divides into 3 watches, and the duration of these watches, of course, changes throughout the year. And all these things are described, and the motion of the planets and so on are described on the second tablet, which doesn't concern us here. We only refer to this first tablet. And those of you who have attended last week's lecture will be a little bit familiar with this already. So in this time, 1000 BCE, the zodiac was not yet invented. They all only had the so-called path of the moon. So you all know that the moon orbits the Earth and wanders through, sort of walks through all the constellations that now we call the zodiac. But the Babylonians had 16 constellations in that area. So they included a list of these 16 constellations whose stars could be covered, occulted by the moon in that time. And these constellations we can now use as an anchor to reconstruct the ancient or the Middle Babylonian view of because the moon has hardly changed. We know where the moon orbits today and what stars he can sometimes cover or occult, and we can reconstruct the stars, the constellations in the path of the moon. Then there are dates given in the Babylonian calendar, um, dates of so-called heliacal risings of constellations. So you know that the sun sometimes covers some of the constellations. They are invisible because they are behind the sun, sort of visible in daylight, so not visible because of daylight. And when they reoccur, this is called a heliacal rise. And the heliacal rises are given here not in the real observable lunar calendar. Babylonian calendar was like the Arabic a lunar calendar, but they are given in an ideal schema, and we can use this to see which constellation is above the east horizon at a specific time of the year. And then there's another list of simultaneous settings. So something rises in the east, rises simultaneously, and something else happens simultaneously in the west. So we can use this to know what constellation was in the west while something else was rising. And this way, we can reconstruct more and more of the constellations. There's also a list of so-called Zikbu asterisms, which are the constellations in zenith or in the meridian simultaneously when something rises in the east. And then there are some constellations, some paths of deities of the second millennium, BCE, of course, which can be used to tell whether a specific object really rises in the real east and sets in the west, or in the southeast and northeast. So these divine information that they gave in their divine system, in their religion, can now be used as a schema of astronomy. Additionally, we found out only a few years ago that they also sort of subdivided constellations in the circumpolar area that never rise and set. So there is a subdivision in the northernmost part of the sky. This subdivision in the so-called, in their terms, so-called path of Enlil is a god. This subdivision distinguishes the ever visible circle from those constellations that rise and set, and is in their religious system or belief is called the deities, the gods of the so-called Ekur temple. The Ekur is the highest temple of the, or most divine temple that they worshipped. And the sitting gods of the Ekur temple are in the very center, in the circumpolar area. They never rise, never set, are always visible. And they are surrounded, and this is sort of similar to a Chinese concept, which is the so-called purple palace or forbidden palace, also in the circumpolar area. And these ever visible gods in the Ekur temple, they are surrounded by the standing gods that are sort of orbiting them. And these gods are called the standing gods because you can imagine like a god sitting on um, on a chair or on a throne, and then some other gods, some other divine deities present to that god. They give office or they donate something to these sitting higher gods. And this so-called presentation scene um, is frequently depicted, and the most famous depiction in ancient Babylonian art is this one, where you have this is the Codex Hammurabi, the oldest civil law that we know from the old Babylonian king Hammurabi. And here, in this presentation scene, in this depiction here, you can see the king, Hammurabi, presenting to the god of the sun and justice. So the Babylonians had the god Shamash, which was the sun. And the sun, of course, as you know, is watching everything on earth. And this is why the god of the sun was considered the most powerful, um, yeah, the most powerful judge, because he could see everything. And that is why he could judge whether something that people did on earth was right or not. So if you go to court and then you want or somebody says something, then the sun can judge whether this is right or wrong. And that is why the sun god is simultaneously the god of justice. And the king here presents to the god of justice because he wants justice for his people. And he wants his civil law to be established and accepted by his people. And this is one of the presentation scenes, and something simultaneously is going on permanently in the sky, where not the king, but other lower gods present to higher gods in order to give the Babylonians their calendar. And this is absolutely parallel to many of the indigenous astronomies all over the world. So this is a concept that many people had. I just want to show you what we then found out and just published earlier this year, that the Babylonian calendar divided these standing gods into 12 segments, but not like our months simultaneously distributed, because the Babylonians have not 12, or their seasons are not equivalently, equally distributed throughout the year. Here in the center, you see the four highest standing gods, and surrounding them, you have two mighty demons for the cold and stormy season where no farming and no seafaring was possible. And then you have the constellation of the plow, when the farmers start plowing the fields and preparing the field for seeding, and then growing their agricultural products. First of all, wheat, and second, the dates. And the dates, of course, take longer to become ripe. And then you have the constellation for the date harvest in late summer or beginning of autumn. And then you start seeding the wheat again in order to have the wheat ready for the second New Year's festival, the New Year's festival in autumn. Um, and then you have the last harvest of the year, which is sort of designated in the sky by the um, constellation of dignity, by like Thanksgiving in North America, like being thankful for all the harvests of the year. And then um, the season starts again until you plow again and you have your first wheat of the year ready for the first New Year's festival. Babylonians had two New Year's festival, one in spring and one in fall, in autumn. Okay, so this is actually a huge cycle. And then later, in the second millennium, they had this seasonal distribution of the constellations in the north. And in the first millennium, they transferred this constellation first from the northern part, the ever visible circle, to the celestial equator and then to the zodiac. And in the zodiac, you have a similar reflection of the agricultural year. You have, for instance, the scorpion, which was for them a symbol of the sun. The scorpion turns to the south, and it's a gatekeeper for them. It is at the place when the sun enters the southern hemisphere and goes to the netherworlds in their terms. So the scorpion is a gatekeeper to the netherworlds. It's also called the bull of the earth, while the bull of the heaven is at the opposite side of the sky. It's when the sun enters the northern hemisphere. Then you have Libra, the scales, which stands for weighting the harvests, for measuring the goods that farmers have produced. You have the Babylonian god, which is called Pabilzag. Pabilzang or Pabilzag is a god that also relates to the god of war, but also to a god of hunt. It's a hunter, it's an archer, and it's a mixed creature. Here's a depiction from ancient Babylonian time. Then they have, because in this time of the year when the archer, the hunter is active, then you cannot harvest anything out there because it's the stormy season. And then you have the benevolent demon of the goatfish, which is a demon. Of course, there is no animal, but we find many figurines, little figurines of a goatfish in the Babylonian culture, because they used it whenever they had a wish to any of their gods. If you want to heal a person, you go to the doctor and the doctor does something with you, but you also have to put a goatfish next to the patient in order to make the gods helping him to become healthy. So the goatfish is very benevolent. It always helps the people. And it's also an attribute of the god of wisdom, which is always depicted with two streams of water next to his shoulders here on a seal from the second millennium. Um, and then, as I already said, you have the other gatekeeper, the bull of heaven, which is at the place when the sun enters the northern hemisphere, when it becomes warm and spring in the sky and in the northern hemisphere. And then you have the warriors that are now called Gemini. You have Cancer at the position of the solstice roughly, and at the hottest time of the year, which is roughly after solstice or at solstice in this area. Not like here, 2 times hottest of the year in the equinoxes, but in the summer solstice. There you have the animal of the lion, a winged lion here, but an animal that represents the highest position of the sun of the year and the hottest time of the year. Our modern Orion, for them, has been in the zodiac, in the path of the moon, because it was a shepherd, and all the planets were the sheep who he protected with his shepherd tool. Here you have the dry season, here you have the wet season, and when you have the time of the harvest and the seeding of the second wheat of the year, there you have the constellation of the Pharaoh, the constellation of the Pharaoh with an ear of grain, some barley or some barley stalks or ears of wheat, representing the successful wheat harvest. But this later was transformed into another constellation, as their constellation of the hired man was later transformed into something else. It was transformed into the constellation of the ram, while they had the constellation of the huge swallow. When the swallows, the birds, migrate to the north, they come from the south and it starts to become warmer. So they migrate to the north. And there, at this position of the sky, the Babylonians, had the constellation of the Great Swallow, which later was transformed together with the constellation of the goddess of love, was transformed into our constellation of Pisces, the two fish. I don't have the time now to explain how that happens, but it's a strange way to change a swallow, a bird, into two fish, which are actually stockfish. And as I said, by only word playing, they achieved a transformation of a man into a ram, which is like magic for us. And by some change in the cult of the goddess of fertility in Greece, goddess of fertility, Demeter, after some volcanic eruptions, led to the transfer or to the change of the Babylonian constellation of the pharaoh with an ear of grain into a maiden with an ear of grain. And this, as I said, happened after 400 BCE with the invention of the zodiac, and probably is related to some volcanic eruptions on the island of Sicily. There was a strong volcanic eruption, and the ashes of the volcano blocked the sunlight. And then they had some misharvests in Sicily and in North Africa and South Italy. And then they prayed to the goddess to give them better harvests. And that is why they emphasized, they stressed the cult of the goddess of fertility, of Demeter, and they projected her into the sky in that position of the constellation that we now call Virgo, the maiden. So then they had invented a new frame of reference. They had changed from the equatorial system to the ecliptic system of constellations, of frame of reference. So they came from their Babylonian month names, which were related to their Babylonian constellations with the agricultural calendar that they named the Babylonian zodiac. And they projected and changed them into the Greek constellations that we now know as the constellations of the Greek or Greco-Roman zodiac. There's another step of transformation in between. So you see there are several steps throughout the first millennium or second and first millennium BCE. There have been many steps of transformation. Looking at the Greek globes that have been that are preserved from Greek or Roman time, we have three globes preserved: some in metal, two in metal, one in marble. And there you can see that all of them depict the stars. Only one of them, the Mainz globe, the bottom right one, depicts the Milky Way. So this was apparently not very important for them. All of them have the equatorial sort of stars at the hour positions in order to make people able of timekeeping, to determine the hours, enable that people to make to determine the calendar and the hours of the day. But the sort of style of painting was different in all three globes. So the stories that they had in mind, the engravers, the globe makers had in mind, were different. And the two small globes only preserve the positions of the planets at their standard positions, as I have mentioned when I explained Eratosthenes. The planets are missing at the huge marble globe. They are not represented. So with that, we can conclude, we can use all this information from different time layers to reconstruct the systematic, maybe unwilling transformation of these constellations. I mapped them here. I took all these drawings from historical documents, from Babylonian seals, from the marble globe, from the metal globes, and I mapped these images to a modern star chart, and this gives you these animated figures. You can find them on the website of the IAU as animated GIFs. So if you want to have this, I can give you the link later to check out later. But concluding, we can say that the constellations have been invented for making the seasons, for making calendars. There have been some religious concepts behind that. And of course, they are really deeply connected to the seasons as they have been, or as they are already also today in ancient Mesopotamia or ancient Greece. Which means if you want to use these modern constellations or the ancient constellations in your system, in your climate, it won't work because you are at the at the equator of the Earth. You have different seasons, you have different climates, and the same images won't work for you. Um, Even if you still had the ancient religion, which you don't have, of course. Again, um, and we can also see that there's a transfer and a change of the constellation of their sizes and so on, which you can have a glance at. It's the other area of the constellation here in the Libra area, because Libra, the balance, the scales actually vanished for a couple of centuries in ancient Greek time. So it was a Babylonian constellation that has been neglected in ancient Greek time and then was reinvented in ancient Roman time, or not reinvented, but um, redrawn due to Babylonian sources in ancient Roman times. There are also some puns, some word plays ongoing. As I said, the Babylonian constellation of Hydra, which was not a water snake, but a huge dragon with a dog head and front legs, with a raven sitting uh, on its tail. And then it was transformed into the Greek image, this one here that I've already shown, into a Babylonian image that is preserved on a clay tablet in Greek time when Babylon was ruled by the Greeks. And then later we have the depiction on the marble globe here, mapped to a stellarium map. And here you can see it doesn't fit the equator anymore. So they invented some mythology, some stories, because it didn't fit the ancient pattern, the pattern from 2000 years earlier. But still, they have a vessel here because of an ancient Babylonian wordplay. And I will take you back just briefly from ancient times to modern times by um, just give you a glance of some other transformations in early modern times, only 400 years ago, not 2000 years ago. As I said, the constellation of the ship, which was named Argo, was changed in early modern times by Dutch sailors when they sailed to Indonesia. The Dutch people, they saw more southern stars, which were not visible in Europe in ancient times. And this is the constellation of the ship in Ptolemy and on the ancient marble globe. And the Dutch sailors then made the ship simply bigger. It was a half ship in Greek and they could have drawn a full ship, but for whatever reason, they made a half ship but bigger. Um, and this is now our constellation, which also has a sail. And in the keel of the ship, or next to the keel of the ship, there is the early modern constellation of the cross. The cross, of course, is a Christian constellation because the Dutch sailors were Christians, and they used this pattern not with a Christian intention, but as a pattern to find the south pole of the sky. The stars have already been known in antiquity, but they were part of the Greek constellation of the Centaur. The legs of the centaur were then used by the early modern constellation about the early modern sailors around 1600 for navigating for the navigation, and this axis of the cross points to the south pole. But they were confused occasionally by a false cross in the keel or in the body of the ship. And this false cross, of course, not takes them to the South Pole, but to a different position. And that is why they then decided to have another constellation, which is called the Cross. And it were actually the Italian sailors who invented this navigational tool and named it the cross because of some um, contemporary of a compatriot poem named Dante Alighieri, and I forgot an H here. who spoke about 4 stars in Italian quadro stelle. We don't know what he means, probably not those stars, but they then thought 200 years after him that he probably referred to their navigational tool. So this was a misunderstanding or a projection by Italian sailors. And simultaneous projections and transformations went on with other constellations, for instance, with Cetus, the sea monster, which has been considered in the constellation of the water, which only exists in Aratus and not in the other Greek authors. And the water is doesn't exist as a constellation today, but a part of it exists, which is the constellation of Eridanus, the river, here in its ancient Greek representation, but then in the early modern constellation extended further south. You can see here this star refers to this star, and the Dutch sailors in Indonesia saw a much brighter star further south and included it into the constellation, so they made it simply longer, the constellation of the river. And then they have the similar shape until here, the ancient, and then their extension. Ciao. I can still see my presentation. You can't. And then they also included another. No, it will appear in a minute. Um, another, because I can already see it, another map. So here you can see a map from a book. And the book has one page here, and some pages later, there is the connection map. And the connecting map displays, here it is, displays the extension. So the Dutch sailors made the constellation even longer in order to use this ancient river constellation, the curly line, to find the southern South Pole. As you can clearly see here, the end of this curly line really is the South Pole. Unfortunately, in ancient sources in the Almagest, it is written the end of the river has the brightest star, and the brightest star is clearly this one. So they thought then the river must end here at this star, and the rest of the curly line is not called the river, is called the uh, small or male water snake. So it's a um, watery line. A watery snake is a water snake is a male water snake. However, they could distinguish between male and female water snakes. That's just a name. And then, even a century later, somebody else invented some new navigational tools. They didn't use the star hopping anymore, and they then invented yet another constellation at the South Pole, which is the octants. And the octant then led to the cut of the tail of the water snake. So that's basically it. And here is the final overview, which is the Babylonian. This is an all sky map of all modern IAU constellations. In orange, I colored the Babylonian constellations, the constellations that have Babylonian origin and that we still use today. The screen keeps telling me that I should stop, but I want to finish this summary. The blue constellations are from the Greek cultures, the yellow ones are Christian, green ones are Dutch, when the sailor went to Indonesia and extended or invented new constellations in the sky. The pink constellations have been added later by a French mathematician. This constellation was also invented by one of the Dutch people, but we do not really know its origin. Possibly, perhaps it has a Christian background. The red ones are invented by a Polish couple of astronomers, Elizabeth and Jan Hevelius. And the dark green one, it was invented by English monarchists, royalists who sort of wanted to honor the English king. So finally, many of our constellations go back to the early, or some of our constellations go back to a calendar of the second millennium BCE. And then they have been transformed and changed into something else throughout the course of the centuries. For whatever reasons, you do not see my summary, which is a pity. But yeah, it's still loading. So you will see it in a minute what I was just talking about. But I am, with that, I want to finish my presentation. I thank you for being so patient for 1 hour and 24 minutes. And if you have questions, I still invite you to ask the questions now or visit me later in office or anywhere else. Thank you very much. Of course, you can ask your questions in Bahasa.
Ada yang mau bertanya?
Everybody's type.
Baiklah. Okay, permission to introduce myself. My name is Rifki, Faculty of Social and Political Science, Political Science Study Program. I like astronomy. Okay, next question. How did people in the past determine which constellation and star belonged to this zodiac sign? First question. Next, how much did the Babylonians and Sumerians know about space and the planets? Thank you.
So, sorry, the verb of the sentence again? How did they?
Babylonians.
The verb.
For the first question is how the indigenous people in that country could determine which constellation belongs to their cultural. Yang kedua?
Okay, I will reply to the first question and then we go to the second. The first question, mm, how they determine, I mean, they, I try to explain it this way. They observed the sky throughout the year and they saw, for instance, always when the Euphrates River has a high water, then a specific star is visible or it becomes visible in the morning sky. So you can use, for instance, the moon, because if it becomes visible then it is in the evening sky. If it is close to short before vanishing in the glance of the sun, then the moon, the crescent of the moon, is in the morning sky. So you can use the moon if it happens to be at the in the morning sky, and some constellations, some bright stars are next to the moon. Then you can determine what constellations are next to the sun. So you have, for instance, you have the old moon. Um, Imagine it like a dial of a clock. Yeah. So you have you know that the 12 is here, the 6 is here, the 3 is here, and the can I paint somewhere? No. Um, no, when, for instance, when the sun is at the position of the 3, then I hope I get it right. The old moon, the thin crescent of the really old moon is at the position of the 4, and the young moon is at the position of the 2.
Jadi semisal sisi matahari itu di jam 3, berarti bulan sabit tua di jam 4, namun bulan sabit muda itu di posisi jam 2.
And therefore you can say at what position the sun is, and without seeing the stars. So if you have one map of the whole, if you know the whole dial, if you know all constellations, then you know some constellations are in the evening, some constellations are in the morning, some say at the position of the 2, some at the position of the 4, and then you can determine what constellation is invisible is behind the.
Oke, jadi dengan kita paham tentang orientasi dari jam, kita bisa ingat, oh sekitar arah jam 2 ini konstelasi ini muncul, arah jam 4 ini. Otomatis nanti kita setelah kita tahu seluruh konstelasinya, kita bisa menentukan konstelasi yang akan terbit atau terbenam setelah atau sebelum si bulan dan matahari itu muncul, gitu.
And then you observe what happens in the environment, in nature. So you observe always when a specific constellation is in the morning, evening, or something. The Euphrates has a high water or has a low water, or then it is the warmest season, something like that.
Jadi kita udah tahu nih, apa namanya, konstelasi apa yang muncul. Jadi kita kaitkan sama keadaan sekitar seperti Sungai Eufrat tersebut, di mana nanti dia sea levelnya ada di atas atau ukurannya di bawah. Jadi dari situ kita bisa, oh konstelasi ini Sungai Eufrat ini lagi naik gitu. Nanti kalau konstelasi ini dia turun kayak gitu.
And then you can make your cultural year. I think now it's clear.
Jadi dari situ kita bisa buat cultural year atau prediksi waktu kultur dari daerah tersebut gitu.
Does that answer both of your question or only one of them?
One. So the second question is how far the Babylonian and also the Sumerian know about the planets?
Oh, well, they knew all the Babylonians and the Sumerians knew Mercury, Venus, Mars, Jupiter, and Saturn. The 5 planets that are visible until today, because they move. You can see them with the naked eye. You can see this star, this bright dot, does not belong in that area. So, and then you can trace it. You can see now it's there, and sometime later it is maybe there or there.
Jadi kita pertanyaannya ini seberapa jauh orang Sumeria dan Babilonia itu tahu tentang planet. Jadi sebenarnya orang Sumeria dan Babilonia ini tidak mengetahui semua planet tapi cuma hanya 5. Kenapa? Karena hanya 5 itulah yang kita bisa lihat di angkasa. Jadi semisal Venus, dia awalnya terbitnya di sini, nanti tiba-tiba orbitnya di sini. Jadi orang bisa menentukan orbit dari setiap planet tersebut dengan pengamatan.
And what is special about them is that they also considered the sun and the moon as planets, which is logical because they can observe the motion of the moon. The moon is now next to this star, tomorrow it's next to this star. So it travels in front of the background of the constellation. The constellations form a sort of screen in front of which the planets travel, and the Greek term planetos actually translates to wanderer or vagabond. So it's a wander. The sun and the moon wander in front of the background, the same background of stars.
Dan hal yang unik juga, hari sama bulan disebut planet sama mereka. Kenapa? Karena term dari planet sendiri menurut mereka itu adalah suatu yang kelana. Jadi backgroundnya itu adalah rasi bintang dan kelima planet tersebut, matahari dan bulan itu juga berkelana. Makanya mereka mengindikasikan semua hal yang berkelana itu namanya planet. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Kenalkan, nama saya Muhammad Rizky, jurusan Ilmu Falak. Di sini saya ingin tanya terkait dasar saja. Bagaimana ilmuwan mengenai bahwa bisa mengilustrasikan sebuah rasi bintang menjadi sebuah gambar di bawah zodiak dan lain-lain. Bagaimana jika kita lihat rasi bintang tersebut memang tidak sesuai dengan gambarnya? Dan rasi bintang tersebut mempunyai makna yang mana apa yang dijelaskan kemarin, rasi bintang tersebut bisa kita mengenal gambar kehidupan manusia.
So the question is, how do the Greek could illustrate the constellation into a stick figure, into a figure that they imagine? Because as a reality, it doesn't match at all the figure and also the stars constellation, and also the figure has their own meaning, such as you said in the previous talks, for sailing, for harvesting, and others.
Yeah, the question of imagination. How can we imagine these weird figures? This is really a question that actually I have to go constellation by constellation to reply to that question, because some constellations are easily imaginable, like the Orion. You have the shoulders and the belt, and that's clearly imaginable. You can, with some fantasy, you can see a man. You can also see a butterfly, I admit, but you can also see a man. It's possible. So if somebody, this is a psychological concept that we have, psychologists call that gestalt seeing, that if somebody says, so shows you, points you to there and says, there is a man, then you will see a man. Although you can also see a butterfly.
Oke, jadi itu sebenarnya adalah kultur, kalau dari beliau sendiri, kalau menjelaskan setiap konstelasi itu mungkin agak susah karena setiap konstelasi itu punya penggambarannya masing-masing. Jadi, kalau hal yang paling mudah itu seperti penggambaran Orion. Jadi kalau kita misalnya lihat di atas, kita bilang, "Oh, itu Orion itu bentuknya seperti, seorang laki-laki yang pakai perisai dan lain sebagainya." Jadi kita bisa ngelihat, oh di sini bentuk pundaknya, kemudian di sini, apa namanya, belt-nya. Nah, habis itu selanjutnya tidak semua yang digambarkan itu memang sesuai dengan imajinasi kita semua, tapi dengan imajinasi yang orang itu berikan. Jadi ada sebuah term psikologi yang mana kalau misalnya kita disuruh nih lihat awan gitu kan, kita lihat, oh awannya bentuknya laki-laki atau awannya bentuknya naga, dan secara tidak langsung kita melihat, oh iya bentuknya kayak ini. Habis itu kita ngeliat lagi, oh enggak, ini bentuknya rabbit ataupun yang lain. Nah itu.
And then there are other constellations like I gave the example with Aries, who was originally a man, and the man in the Babylonian or Sumerian culture was a little bit imaginable, not very clearly, but you can see a man in that area. And then they transformed it into a ram, Aries. And Aries, the ram is definitely not imaginable. You have 3 stars, and then they say that's a ram. But this was definitely not imagined by anybody in antiquity, because this is just a wordplay. This is this is just a wordplay. The Babylonian term has 3 syllables. It's the Babylonian term for this constellation is Lu Sun Ba. And they abbreviated this term as we do it now in SMS style, in text messages. They abbreviated it, and then first they left out the Lu, then it became Hun, and then they left out the Ga, then there was only the Hun, and the cuneiform sign, how they paint the Hun letter, was or is very similar to the letter that is used for Udu. So they had the term Luchunga, which designates a man. They abbreviated it, and then it became, by abbreviation, the sheep. As if you abbreviate Meso for Mesopotamia, as you leave out the Meso, you leave out the Tamia, and you have only pot, like a pot, as a remain.
Jadi, salah satu contohnya itu adalah rasi bintang Aries. Nah, tadi kan kita udah dijelasin kalau semisalnya setiap ada 3 suku kata, itu nanti dia akan disingkat. Kayak kita nyingkat di SMS. Jadi, yang awalnya 3 kata, kemudian 2 kata di awal dihilangkan, dan di Aries itu yang awalnya menurut bahasa mereka itu artinya laki-laki, karena disingkat dan satu kata itu akhirnya menjadi, arti yang berbeda, yaitu domba. Makanya transformasi gambar dari man ke sheep itu berubah karena hasil dari misinterpretasi tadi.
Is that okay?
Thank you. Ada lagi yang mau bertanya? Sudah? Oh, iya. Okay, thank you for attention. So, there is jadi dahulu kan ada zodiak itu ada 12. Jadi selama matahari berputar selama 1 tahun ada 12 zodiak yang dilewati matahari. Kemudian ada satu tambahan dari rasa zodiak yang baru, yaitu Apicius, Apicius ya itu. Apicius. Nah, kenapa ada tambahan dan baru 2011 mungkin ya, ada tambahan zodiak baru ini, apakah ada kriteria tersendiri jadi ada tambahan zodiak? Terima kasih.
Okay, the question is, as we know that the number of the zodiac sign is 12, right, ma'am? So there is a new edition of the Ophiuchus in 2011 from, she said, from NASA. And why is there any addition? The first question. And the second is there any criteria to remark that that is a constellation sign or the zodiac sign?
Yeah, thank you very much for that question. I didn't have the time to go through these details. The constellations have been defined internationally before NASA was founded. So NASA did not invent a new constellation.
Jadi sebelum adanya NASA, udah ada lembaga yang memberikan nama konstelasi, dan NASA bukan yang memberikan nama konstelasi.
So the constellation of Ophiuchus, existed before NASA and before 2011, indeed even before the IAU in the 1920s defined the constellation. Ophiuchus actually is an ancient constellation. It existed in Greek antiquity, it existed in Roman antiquity, and it probably, we are not really sure, but probably it had a Babylonian predecessor. So there was a Babylonian, maybe king, maybe god in the sky called Zababa, and this was at the area of the constellation of Ophiuchus, the Greek one.
Jadi sebenarnya konstelasi Ophiuchus itu sudah ada sebelum NASA, bahkan sebelum IAU itu meresmikan nama-nama konstelasi. Dan nama konstelasi ini sudah ada di zaman Yunani, zaman Roma, dan mungkin ada di zaman Babilonia, yang mana salah satunya ada pada gambar atau area di nama dewanya Babilonia.
So there always has been this constellation, a constellation of any male figure. It has been there already 1000 BCE, and throughout all the history, nobody had rejected it. The interesting thing is, why did the Babylonians, when they invented the zodiac, not name this area Ophiuchus when they already had this constellation, or Zababa, or whatever? So why did they name it Scorpius and not Ophiuchus? And this is the interesting question. The answer is that we actually don't know, because we don't have a written source about that. We don't have a written source that literally tell us something like, now we invent the zodiac and we do it this way. That doesn't exist. We have to reconstruct everything. But the highly likely case is that because of the calendar, they always use, like in Arabic, in the Islamic calendar, the important thing is the beginning of the month. So the important thing here is the beginning of the sign. So when they make a division of the path of the moon, the division of the whole circle, 360 degree, I guess that's the battery of the microphone, because I didn't do anything. So if they switch, if they divide the sky into 12 equal sections, then at first the moon or the sun or whatever planet enters the Scorpion first and then goes into Ophiuchus. Still, your question is really important, because the issue why NASA or modern astronomers now sort of include it into the zodiac or into that area is to make people aware that the sun actually spends 3 weeks of the month in Ophiuchus, and before it's only for 5 days in Scorpius.
Oke, jadi sebenarnya rasi bintang Ophiuchus ini udah ada sejak lama. Namun, gini, jadi Babilonia itu juga udah tahu kalau Ophiuchus itu atau Zababa itu memang ada di ini ya, di jalurnya matahari ya. Tapi salah satu alasannya kenapa mereka tidak memasukkan, nama Ophiuchus itu ke dalam zodiak atau ke dalam rasi bintang yang dinamakan zodiak, karena kepentingannya ini adalah dalam penentuan awal bulan. Sama kayak kita kalender Islam kan pentingnya itu kan di awal bulannya. Jadi penentuan awal bulan mereka itu ada pada Scorpio, bukan pada Ophiuchus-nya. Nah, alasan kenapa mungkin untuk zaman modern ini NASA ataupun lembaga yang lainnya itu menggembor-gemborkan bahwa kita nih punya nih rasi bintang yang namanya Ophiuchus di zodiak itu tadi. Karena kita tuh tahu kalau sebenarnya Ophiuchus ini sudah ada dan matahari itu sebenarnya hanya menghabiskan 5 hari di Scorpio. Sedangkan untuk sisanya yaitu 3 minggu itu berada di Ophiuchus begitu.
Are there more questions?
Okay, thanks for the opportunity. First thing first, my name is Muhammad Fajri Holilizen. I'm a master student in this university, especially in the Faculty of Sharia and Law. For the first, I would like to say apologies for you because I can send my question in English language. I'm so sorry, Miss. But I feel honored to meet you here today, and your material that you for us today is makes me so much. Saya lagi bahasa Indonesia. Pertanyaan saya, Miss, tadi saya sangat tertarik dengan pembahasan Miss Susan yang membahas tentang banyak dari astronom-astronom terdahulu seperti Ptolemy dan Hipparchus dan sebagainya yang menuliskan karya-karyanya itu juga dalam bentuk putri kayak gitu kan. Lah di Jawa sendiri saya beberapa kali menemukan kait teks-teks ini apa historical literature from the Javanese Kingdom that yang dituliskan dalam ini apa namanya bahasa-bahasa sastra kayak gitu dan ini sangat hiperbola sekali di dalam pembahasannya. Tapi di dalam maknanya itu saya menemukan terkait banyak materi keilmuan khususnya dalam astronomi. Eee, apakah bisa dengan literatur yang penuh dengan bahasa hiperbola dan juga pengandaian ini dirumuskan, direkonstruksikan kembali seperti yang sudah Miss Susan lakukan? Terima kasih.
Okay, he is curious about your presentation of the Ptolemy and also the Hipparchus and the others poet that create poem. And he said that in Java, he also recognized there are several poetry that describe the sky, but in hyperbolic style of language. And he asked, could we reconstruct the poem from that poetry to a new star constellation images like that? Because of the language is so hyperbolic, and he asked, could it be possible to do that so?
That's a difficult question. Thank you for but it's difficult. I cannot, I cannot answer it yet now for sure because I don't know the poem. But I strongly encourage you to do that. And I mean, both of you, because I mean all these things are highly interesting to merge your, as I said, all what I presented here, everything that was invented in either Babylonia or in the Greek culture or maybe Greco-Roman culture. There is a huge mess ongoing because the Greeks in their area of the Mediterranean have some specific winds that only are blow there in the Aegean Sea and do not really work in Rome and in modern Italy. Still, the Romans took over the Greek rules. And the Greeks took over some farmer rules from, I don't know, Anatolia or from Mesopotamia that do not really work there. But it roughly fits, I mean, halfway. If you now go to here, to Java, then it doesn't work at all because you are at the equator, even at the southern hemisphere. So if you use these ancient indigenous Javanian, I don't the English term. These indigenous concepts, if you use your own climate-related rules, then you will create something new, and you will learn about it. You will be able to use the whatever origin international constellations and relate to your culture and relate them better. So yeah, that is a problem. But me, of course, I cannot tell if you can deal with your ancient languages. So this is what you have to negotiate with your specialist, maybe at the Faculty of Languages or anything. So I guess you understood, but maybe you can give a summary in English, in Bahasa for everybody.
And he also said that if there are any new approaches to analyze that, maybe he would be happy to know about that. Could you suggest the new approaches for?
Um, there are some new approaches, it is specifically in the framework of the digital humanities. Digital humanities provides first the digitalization. So if you have a written text, then they will digitalize it. Second, they have language models, as you know from what's it called, Google Translate or anything like these translation machines. Um, and this is already developed for ancient languages. It's not really good, but for instance, for Latin, it well, Latin is very common, so this language model is already at a very mature state. But digital humanities people already develop it for other ancient languages, like cuneiform. That's not mature, but they already can. If they can do that, they can already do that for the Javanese language. Um, and you can use these tools then. Um, Also, maybe, I mean, it depends on what you find. Maybe you can use historical data or climate data, weather data from Java. Maybe I mean, what is really interesting and very useful for reconstructing what I told about the Mediterranean are data about volcanic eruptions, if you have um, these ice cores that they drag from the poles, from the South Pole and the North Pole of the Earth. If you have a strong volcanic eruption here at the equator, then the ashes of the volcano will go north and south, and they will be found in ice cores in some layers of the past. And all this data can be used to reconstruct historical climates, historical landscape features. So you need to use geological data, climate data, and everything from the past. It's a huge project, probably not only one PhD, but many. So maybe your PhD and your PhD and somebody else's PhD. I invite you all to develop your subject towards that.
Oke, jadi tadi Miss Susan bilang kalau mungkin di puisi itu yang kita temukan, kita bisa mengkajinya dengan berbagai pendekatan, mulai dari pendekatan digital humanity, kemudian pendekatan dari cuaca, pendekatan historical. Jadi kalau misalnya kita ini kan sebagai salah satu negara dengan tinggi. Nah, mungkin di bawah layer kita itu dijadikan sebagai data history. Jadi kita bisa menentukan bagaimana landscape pada zaman saat itu, kemudian bagaimana cuaca, bagaimana kondisi alam sekitar. Nah, selain itu beliau juga menyarankan kita untuk melakukan banyak penelitian untuk ini ya, etnoastronomi ini. Jadi bisa nih teman-teman untuk bakal judul skripsi gini, semisal rasi bintang, kan kita nih bahas tentang rasi bintang ya yang ada di manuskrip-manuskrip. Nah, salah satu manuskrip contohnya misalnya Serat Serat Widya apa ya? Serat Widya Pradana. Kemudian ada Serat Centini. Itu juga ada catatan-catatan astronominya. Dari situ kita bisa rekonstruksi catatan-catatan tersebut. Misalnya kita gunakan si rasi bintang Orion nih untuk penanda apa namanya? Penanda arah atau rasi bintang Crux untuk eh, apa namanya? Sailing dan lain sebagainya. Diambil dari ancient manuskrip tersebut. Nanti bisa teman-teman spesifikasikan ke permasalahan-permasalahan awal bulan kah, mau tentang kalender agraria, atau mau tentang um, arah, arah kiblat, tentang waktu sholat dan lain sebagainya. Oke, oke, terima kasih. Ada lagi yang bertanya? Sudah? Oke, terima kasih atas pertemuan hari ini.
Terima kasih, and thank you all. I know it was a long time. Thank you very much for staying so long.
Oke, sekarang sesi foto ya.